customers on Service Fabric. So we encourage you to watch some of those because they tell you a lot about what we've done as a release of build, and also some of the features as we're building in, as we look ahead into our roadmap, especially around containers, and as we look towards Linux and the next releases that are coming up as we release sometime in the summer, the end of June, July timeframe. So we'll post those in the Iron window, and we encourage you to watch them because some of them were interesting in terms of what you want to do. And we can ask questions about those, so please ask questions about some of those things. So on that note, I guess we should
get started with the questions. So if you've got questions, you can enter them into the chat window. We're looking there.
T-shirts. We got a quick one about
t-shirts.
Yes,
t-shirts. You also talk with us.
There will be more t-shirts.
If you come, there will be more t-shirts, and if you can come and visit us in some way, or we encounter you, we're going to get a lot more of them printed.
Or at Ignite. If you're at Ignite.
Oh yes, at Ignite. Come to Ignite. We will have piles of t-shirts.
Mountains of t-shirts.
Mountains of t-shirts. Yes.
So there was a question from Marcin about the volume drivers and disaster recovery. So since that particular volume was backed by a stateful service, it's exactly the same as it would be for stateful services. But the other volume driver that we wanted to do was one backed by blob. And then it's normal blob replication to other geographies.
Yes. And we're working with the Azure storage team as part of the next phase of planning. So in Azure, every 6 months, we sort of plan big items of what's happening. And we just talked to the Azure storage team last week, and we were encourage them to build a volume drive for Azure storage that will hook up to containers. But there's no commitment on it just yet, but they're pretty excited about doing it all. Yeah. But we will certainly build one ourselves on top of our storage.
Yeah, so we will also have a Service Fabric volume driver.
Which will be incredibly fast, won't it? Because our storage is incredibly fast.
Indeed.
Yes.
So if I can ask, I'm sorry, is it that there is a separate stateful service that backs up the volume for all the containers? So it's like a system service, or it's like a bunch of separate stateful services dedicated for this purpose?
So what you saw in the demo is just a prototype, keep in mind. So there we actually had a stateful service, a reliable dictionary service that was actually doing the backing up, replicating and taking care of the volumes.
But it'll be far more efficient than that when we write the real thing, because you've got to write a real driver that effectively maps volume, the file system down to our storage layer, where we have our own log system and driver and things. So, but in effect, the way to think about it, on a per container basis, you have replica copies of the file system that mapped it.
And whether it is a separate system service or not is something that that we haven't yet decided, but we just started to work on it.
Yeah. Next question was the Chaco. Good timing.
Okay.
Hey, Chaco. Yeah.
Hello.
The status of the patch orchestration service.
So we are currently rolling that out. There is a setting in SFRP which we need before we can give the patch orchestration application out for customers to deploy. So I would say the ETA for it is end of this week. We had some issues with our own deployment technology, which ran into some of the WannaCry issues. So that's why it's running out slow.
Yeah. Just taking time.
Yeah, but it's available effectively for people to take that. I mean, highly encourage that they put the patch orchestration application into your cluster, yes, to be able to do your patches, yes.
Yes. So there are three options today. If you want to do something today, if you go to a blog, there actually is a manual script which you can deploy, and that certainly will be a fine way to go about it. The second thing is, if you guys cannot wait till the weekend, then if you want to be in the preview program, we can actually put you there, and there's another manual way of applying this application as well, or just wait for 3 days.
Wait for 3 days.
Okay.
Yeah, so that happens over the weekend. And there's about
availability zones over there.
Okay. So what is the question?
What's happening?
What's the deal?
What's the roadmap for availability zones?
So a couple of availability zones is actually a very highly misused word. So let me just explain this a little bit. So Azure wants to enable you to select the number of availability zones in which you want to deploy a cluster or deploy your VMSS. So today, VMSS, at least in preview.
What's an availability zone?
Yeah, availability zone basically is a portion of our region set up in such a way that one of the availability zones going down will not affect the other one. So if you are familiar with, say, the availability zone concept in AWS, it's almost the same thing.
Are they physical data centers?
They're physical data centers which are separated by around 50 kilometers out. So that is what AZ is.
Same region, but different physical data centers.
Yeah.
It's the same region.
Physical separation, so that if one loses power, the other ones aren't.
So it's the next level of availability over a rack within inside a data center.
It is far more than that. Actually, is truly separate buildings which are separated by land. And then there are separate power supplies and everything else.
So what's happening? Are we going to be?
So today, large data sets support in VMSS does allow you to span multiple AZs, or at least in the preview land. So that's something which we Service Fabric are not supporting because we are not able to compare the FDs and UDs across these. So we're working on it at this point. So if you ever want to do this, so I would strongly encourage you to set up VMSS per AZ. That means each of the node types would be in a different AZ, and then you should span your clusters across.
Yep.
That is the only supported way to do it. And if you currently,
yeah.
And
Till
then
we get a few things from the rest of the Azure Compute Stack.
Yes.
It's not currently safe to span a node type across different AZs.
Yeah.
So we say just create different node types, one in each AZ, and that becomes one big cluster, and then you're kind of open.
So then 1 second. So then what happens? There's also a couple of settings which you will need to do. So if there is anyone interested in it, just let Matt or I know. We'll give you some guidance on it.
Why don't we write something down?
We will write it down when it's fully supported.
When's that time frame?
Maybe Q4 of this year. Q4 of this year.
Okay.
So before that, if you wanted, so that is the only time when the guidance would be to span your replica sets across node types. That is the only time when we will say, yes, you should span it.
We really want that to happen, but again, there are some things that we need from the underlying platform before we can turn it on safely. So you can manually set it up today, but there's a few things in order for it to be kind of automatic or natural that we want to make sure get
it sounds like, given it's Q4 of this year, we probably should do some guidance sooner rather than later.
Okay, so
what you can do.
Sounds good. We'll do that. Okay. Yeah, it's something we know we need to go do.
Yeah.
Chocolate, just to make sure, does it mean that you are able now to run system services on multiple node types during some magical switches?
The answer to that question is yes. That's why I said, if you reach out to us, we actually do have, this thing is, we have this working internally. It is not something which is error-proof. It has to be carefully orchestrated. The answer to your question is yes. At that point, the system services, basically the primary node type as a concept goes away. You would have seed nodes which will span. There will be the system services will span across AZs. Yes.
Yeah, and you have a whole bunch of other questions there, Marcin, about spanning clusters and things like that. I encourage you just to reach out to us. That's not really a scenario that we support publicly today because it is very hard to set up. And as we said, there's a bunch of little caveats and things like that. We should also talk with you about why you want to run across multiple data centers, because that's really only for avoiding particular types of errors, and there might be other ways to do it, particularly if there are requirements around recovery point objective, recovery time, things like that. So unfortunately, it's not just a flip a switch and it works kind of situation. And it might, for a lot of people, you don't necessarily even need it. I want it because it's a lot of fun, but it's something that we need to talk about a little more. So.
And then the other thing is one other thing, you are going to have more VMs when you span more AZs. So that's something which has to be very crisply understood. So you're not spanning for COGS reasons. You would span for more reliability reasons. So that's something which everyone should understand. Whenever you talk about cross-regional, cross-AZs, all these mean more VMs.
Okay, let's move on to this next question after it says, we started Service Fabric in terms of communication services. We are thinking of using a reverse proxy. However, how can we do load balancing between instances rather than random?
If you're talking, if you're talking about stateless services, it'll be random, but I'm curious what you mean by load balancing other than just random. if you're looking for something a little bit smarter, like actually probing to see how much load each instance is generating, that's not built in today, but it's something we've considered doing. The other alternative, though, is you can, so this is if you have a single stateless service with an instance count greater than 1, it'll randomly distribute between those. But if you have multiple stateless services, like multiple instances, or multiple named stateless services, then you can do your own load balancing because you can then decide which one to send the traffic to. So that's another way to do it.
Yeah, we've seen people do things like that where they're keeping track of metrics or some amount of work that's going on inside those stateless services.
Exactly.
And then they're figuring out that that's coming back to some gateway. And then that gateway is saying, well, I could route to this one next, but I know that it's still doing a bunch of work that I already sent it.
That's right.
So I want to select a different endpoint and send it to that one instead.
And that's something that your client, the reverse proxy doesn't do this for you. It's something that the client on the other side has to do by asking questions of those services. What load are you under right now? And then do I want to send traffic to you? So, but the reverse proxy will just send it to that service directly. And if it does have an instance count greater than 1, that's just random distribution.
Let's see, what's next?
Okay, I think it's on-premise one.
We were.
Did you get this one from Marcin?
We kind of got that from Marcin. And as far as Marcin is the questions about how Cosmos DB works, I will defer to the Cosmos DB team to answer how Cosmos DB works. We're not really going to give away too many of their secrets. They do have multiple clusters in multiple different geographies, and they've done some things to hook those up. That's, I think, about as far into their implementation as we're reasonably allowed to talk about, or they'll send somebody over to whack us. They do have a lot of forums and things like that where they are taking questions. So maybe reach out there and see how much they're willing to talk about in detail.
Okay,
that's far enough. That's exactly what I wanted to learn.
Okay.
Okay.
On an on-premise installation, this is from Micah.
Micah.
We have gigabytes of temp files.
So Michael, I think I would encourage you to file a CSS ticket. We want to look at your cluster. Basically, it looks like there is some setting which is not enabled properly there. We should all these log folders should rotate, and it should not consume your local temp drive unless that happens to be your own state. So we have to look at it.
Yeah, it shouldn't happen. So it's either an issue we need to fix.
No, it's just a setting. So we just need to look at your cluster.
Okay.
Yeah, just file a CSS ticket, please.
Okay, single node test cluster.
Is it possible to run a production workload on a single node cluster?
So this is an interesting question, right? So in our build booth, basically a lot of customers came to me and asked this question, especially the consulting group. So single node cluster is not meant to run production workloads. So if you do, I mean, there is no time bomb, there is nothing in the system which will prevent you from shooting yourself in the foot. So our encouragement is never to do this. That is where we stop.
Yeah, the primary reason why we did it was because we had a lot of people who had MSDN subscriptions, and they wanted to be able to say, I wanted to go and stand up a single node cluster as the first way of doing my testing without having to take the cost of doing the minimum that you have is 3 today.
So it's really cost savings for you as you're doing development and testing.
Yeah.
But in a real production scenario, you would never do that.
Yeah, because it doesn't give you anything in terms of availability. If your node goes down,
Right.
then at that point you're done.
We have floated the idea of allowing single node environments for production workloads, but it's a very specific agreement that a customer would have to have with us, the Service Fabric team, because we want to make sure that everyone understands what you're getting and what you're not getting. So for example, if the only requirement is for you want to run basically a single node workload, and the requirement that you're trying to avoid is having to rewrite that service on a technology other than Service Fabric just to get it to run on one machine, and you don't have those high availability, high durability requirements, you're not going to be trying to do upgrades with no impact. So long as all that stuff is understood, then that's a special kind of one-off thing that we might be willing to do, but we have to be very very clearly communicative with both whoever's building it and whoever the actual customer is about what they're getting and why. So that is something that could be considered, but again, it's a very special kind of one-off environment, and we want to make sure everyone understands what's going on.
That's exactly my case. I just want to make sure that I don't lose any consistency. I need consistency guarantees. I don't need any availability guarantees.
Yeah, so the consistency stuff, you still might have problems, because what will happen is you can do some write there, it gets replicated to the local disk only, and then that one machine dies. If that one machine dies and goes back in time, then you've lost your stuff. And so you don't have a full consistency guarantee. It's very hard to do with a single machine. So any number of things can go wrong. And that's, again, why if you're going down this route, we recommend you phone us up and we talk through exactly what you're trying to build and why that's an interesting scenario for you. But yeah, the default stance is that it's not a production environment. Can't be.
Okay.
It's finally one node.
Yeah. All right. What's next?
Until recently, there was a problem where you could only apply a security access policy at the application level rather than at the service level. Is this still the case, or is it supposed to be this way?
Well, no, the way, let's see, hang on, let me read the rest of the question. Is this still a case, or is it supposed to be this way? The case is that we want to segregate applications by node type and only install certs on a subset of nodes or applications. Okay, so actually, although we define the policy in the application manifest, that's where we just define all our policies for the things that can be used in the services within them. So the application, the security access policy, which is giving you effectively credentials or the access policy to the process that you're going to launch, you then apply to a particular service within inside the application. So the run as policy applies to a service A or service B, and you want to run it under either a local host, or you can run it under on Active Directory, for example. If it's on premise, you can run it under a group managed account or one of the other Active Directory accounts. So it applies to actually at the process level that you put this thing on. And then in turn, that allows you to ACL all of the files, or the local working remote file system that it generates when the application is deployed inside there. So if your question is, I want to segregate my applications by node type and only install certs on a subset of nodes, it sounds like you're trying to ask for, I know only this application will be deployed on these machines, but the run as policy is also at the process level, so it doesn't need certs.
Well, what we typically would see things. Yeah, go ahead.
Let me zero in on this. Our front end, stateless service, needs to access the certificate. Our back end does not. We already have things going so that the nodes the services are separated onto different nodes. The node affinity, it works great. Yes. But I can only apply the security access policy at the entire application level, requiring me to distribute my certificates across both node sets.
Yes. Well, okay.
The certificates on the front end node sets, the back end node sets should never even know about the cert.
Yeah. So that's
now that policy can only be applied at the entire application level, not at one small set.
Yeah, it's not really so much the application level, but the fact that any one of those applications can be deployed on any one of those machines. Yes, and so you have to put the certificates across all the machines. Is what you're saying?
No, I've already got the node affinity regulating which sets of machines, which node types, which applications are going to.
Yes, but effectively those apps will only be deployed on those front end machines, correct?
No, it's that I see what you're saying, Greg, and what we need to do is make that security access policy kind of service type or service package specific rather than where it exists today, and then that way, Service Fabric knows that when we're starting up this service type on this node that we shouldn't expect that cert to be there and we shouldn't go do all this work. That way you can actually make sure that today we require you to put to have that cert deployed onto that other VM scale set as well. Otherwise we report issues that we can't access the cert.
So there is a way. Do you have two node types today?
Yes, he does.
Yeah. So I was about to say the way you can work and get this to do it in another way. So if you have two node types, what you should be able to do, which we haven't just tried out yet, but it should become, is that each one of, they've introduced now with VM scale sets, and I'll follow up on this concept of managed service identities. where the VMs themselves have an identity running on them that allows you to pull certificates down for a node type from Key Vault and effectively keep them updated. So you may be able to have the managed service identities turned on for the node type for that VM scale set. Only just pull the certs that they need for your front end machines. Make sense?
I think so, yeah. No, I'd love to hear more detail on that.
Yeah, I think it's that you'd stop using this particular mechanism for setting things up and you'd switch over to that. I think that as that feature, that's again something from Key Vault and VM scale sets. As that gets a little bit further along, you'll see more guidance from us about how to do that.
Yeah.
As it is today, the only answer you'd really have is to create two different application types. One with service type 1 inside of it, one inside of service type 2. And then that way you could set the security access policy differently or not have it for one of those applications.
Yeah, so it's a good feedback. As we go look towards the future, we are trying to move towards a direction where certs do get deployed when applications get deployed onto the machine, and that is certainly the direction we're trying to go.
Marcina asks about running stateful services inside containers and changing stateful services architecture. Don't really know what the second part means, but
the first part, absolutely, by Ignite we should have support for running stateful services inside containers.
Yeah.
By September.
Yeah.
Yes.
Chaco's rolling back to a previous conversation where we got on Chaco's case for not saying the middle of May instead of build. So he is now giving back to you the gift of
Dates.
September. Yes.
Rather than aliases for dates.
A conference in mid-September. Yes.
Yes.
But that is the plan. What is the best way to have a larger ephemeral disk, increase VM size, or create managed disk?
So if you use an attached managed disk, you are going to pay for it. So that's something. It's an option you already absolutely have. The only difference here is if it's an ephemeral disk, your state doesn't replicate. It's not replicated by Xstore. So now I would say you just have to weigh your costs and also the latencies which may be introduced by using an attached managed disk. So it's something which you need to figure out yourself. Easy answer to this question is go to the next level of VM size.
Just make the VM bigger. That's the simple one.
So the other thing which I have to also, this is a very dangerous question, so I just have to give you some more caveats. So just because, say for example, let's take that example of you have lots of oodles of money, you just decide V15 is my SKU. So it gives you 2 terabytes of data. So it doesn't mean that you stuff 2 terabytes of data in that thing, because you have to think about disaster recoveries. If, for example, you lose a few machines at the same time, that means that much of traffic is being now pumped through this narrow, like 10 gig pipe which you have. And so you have to figure out, okay, how long does it take to create another one? So it is not just the size of the disk which really matters. You got to think through the state, how much of state you want to store and how much of bandwidth you have to pump the data out in case of a disaster. It doesn't have to be a true regional disaster. It just can be that you're losing a quorum of machines or very close to quorum, and you're creating a new replica. So think to that, and then you'll get to the answer. So there is no real golden rule here.
So question from Greg. I've heard in previous call that it was possible to host web endpoints, things that be installed on web server in the DNZ, and logical services, things that would have been deployed in an app server on a backend network in the same cluster. So yep, you can do that. Question 1, is this even a good idea? Question 2, if it is, how do you create the DMZ? And question 3, where should these servers live? You want to take the first bit? And I'll take the...
It sounds like NSGs to me.
Yeah.
That sounds like you have two node types, and one is designated your front-end node type, one's designated your back-end node type, and when you deploy your services, you just put placement constraints on them so that your web service only runs on the front end, and your back-end service only on the back end. And then you can put different network security groups around those two node types to keep them kind of apart from each other.
And that way you're regulating the ports and the traffic that is flowing between the front ends and the back ends.
Yep.
You'd also probably make sure, I don't think our default setup does this, but you'd make sure that the back end node type doesn't have a public Azure load balancer associated with it.
Right.
So you'd be going only from public internet to the front end node types. You'll be transiting from the front end node types to the back end node types through that NSG.
That's a common setup usually. Your backend node types have no internet-facing ports open at all whatsoever.
Yeah. In fact, I think the default now when we create a cluster is put an NSG in it. Is that right?
The
We
default.
do NSG then.
Yeah, default from the portal when
default
you creates it actually puts an NSG in there. It actually is a very generic one. So the rules actually allow everything. You just need to close them. So other thing which I would suggest is if you truly are thinking about DMZs and MZs, then anything in the MZ, you can actually now also specifically say that unless a particular IP address is from this particular subnet, which happens to be in this DMZ, you will not allow the traffic to be even accepted in the backend. So you can take it a second step further. So all these are NSG rules. So I would say when you start playing with it, you can do a lot of things with it. So NSG is the answer for you.
Yep.
Okay. Can anyone point me to a link about a single node test cluster? Is it in the docs, Chaco, or just go and create a portal and cluster and you'll see it there?
Yes, if you go to the portal, certainly you'll see a little dialog box and click it. There is also, I have a talk which talks about that from build. And then in the PowerShell, there is a specific example as well.
And did you post this talk at the beginning?
Yeah, I put up all 3 major talks that we did.
Okay.
Yours, Chaco's, and I think one of the customer ones.
Yes. Okay. Guidelines around sharing event source derived class.
Yeah, this is a long one, but
this is tricky.
basically what he's getting at, I've run into this too, and this is kind of a pet peeve of mine, is that it's very difficult if you're writing a shared component. How do you log out of that shared component through event source? Because event source gives you the singleton with an attribute on it that tells you what the source of the events are. So this is a pet peeve of mine too. I'm not sure what a good answer to this. There's one thing that happened with event source in .NET 4.6.1, I think. Now you can instantiate an event source instance and actually pass it. You can pass it the event source name rather than attribute it on the class. So that could help because now you can just use dependency injection to go and inject these event source classes into your components. But overall, I mean, this is kind of hard with event source, and the whole idea of doing this structured logging, where you have dedicated methods per event that you want to log, makes it really difficult to use in components because you don't necessarily know, unless you write interfaces for all these things, and then all of your event sources they have in services have to derive from these interfaces or implement them. It's pretty hard to do. I would suggest posting this question on Stack Overflow, and I'll see if I can point Carol over to it, who is pretty familiar with this. He's not on the call today, unfortunately, but if you post this one on Stack Overflow, I'll have him take a look at it and see if he has any suggestions for you there.
Sure. Thanks.
So do it, yeah.
Okay.
What's next here?
Azure Functions runtime on top of Service Fabric.
Haven't tried it yet.
We haven't tried it yet, but I mean, the thing I think you could probably try that's kind of maybe a fun thing to do is they shipped functions that run inside a container now. So they had a container version of that. So you can take that container and run it on Service Fabric and run the Azure Functions on Service Fabric that way. So go off and try that. That should just work because they allow you to run that in a containerized workload there. One thing we run into.
Hold on, I think we skipped one.
Yeah.
Yeah, so we run an on-premise Service Fabric and have public-facing Web API services. We have to set up our own load balancer. However, any recommendations on how do we update endpoint when it's moving? I assume you mean when the service moves.
Yeah.
And when the service moves, it'll update with our naming service automatically, but the load balancer either has to know how to talk to the naming service, or it can do something like what the Azure load balancer does, which is probe all the nodes that it wants to talk to. So it depends on what load balancer you're using, what capabilities it has.
Yeah, you'd have to write most of these load balancers have some APIs that you can call.
Yeah.
And then you have to write all that code yourself that when the application gets deployed, it opens up the ports.
If you're using an F5, it has a pretty rich API to do this kind of stuff. So your options really are either probe the machines to see if anyone's responding on the port and maybe a protocol that you want to use, or if you can get our SDK in there, get our libraries in there, or even make HTTP calls out from the load balancer. You can ask the naming service for the endpoints, which will always be up to date.
Right.
So that's the best choice if you can do that in the load balancer.
I guess another option is kind of what we've historically had to do inside of Azure, where we can't program the load balancer, we can't inject the SDK, it can't make HTTP calls. So what people end up doing is they write another stateless service which sits on all the machines. The load balancer is effectively always talking to that little stateless service, which just acts as a gateway and a router, picks up the message that's coming in, figures out what, where the service actually is, and then routes the call accordingly. It's unfortunate because that's a whole other service that you have to run.
Yeah.
But if the load balancer isn't rich or isn't programmable or you can't really intercept it or anything like that, then that's kind of the only option.
Even then, you do still run into a similar problem, which is even if you have a service running on all the nodes, there is a chance one of them might crash.
Oh, sure.
And in that few second time span where we spin it up and it starts starting up again, you want your load balancer to take that machine out of rotation temporarily. So again, you'll need probes, at least probes.
Almost everything does have that.
Everything has that, yeah.
But yeah, that's it. That would be a case example also if you were doing upgrades, right?
Yeah,
during the upgrade, the gateway even would go down a gateway.
Gateway would go down, exactly. Yeah.
So
you really need to configure that load balancer.
Yep, ideally.
Okay, so let's go on to Greg.
Yep.
But did you get the function that's
function,
runs on
yeah.
or something? Okay.
Yeah, jumped around a little bit. When coding a microservice that is different for the developers that we need to handle logging differently, large increase in the cost of building the service fabric cluster. We now needed to understand to use event flow and set up elk. Is there anything any other major changes that we need to consider from the development perspective?
Just for logging specifically?
Yeah, it's just how to help with logging. I mean, at the moment we make this recommendation of event flow, and Deep, I don't know if you want to talk to this.
Yeah, sure. I'm curious as to why you need to set up both event flow and an elk
No,
cluster.
he's just saying it with elk.
Oh, okay. Sure. Major changes. No, for now this should be fine. The future of event flow is that it's going to be rolled into AI SDK in the long run. But if you're using event flow as it is today, there should be no problems considering it's always going to exist as a standalone. No, we can't hear you. Exist as a standalone offering that you can continue to use.
Yeah, maybe ask your question if unmute your mic. We can answer your question.
I guess there's one consideration to make, but this is more general, which is that you're in a shared hosting environment now, whereas traditionally in the past, usually you have dedicated servers for dedicated tasks. But now you have a potentially large number of services or even processes on a single machine, and so you have to consider the way, especially with event flow talking directly to App Insights. I'm not sure if it's the same for Elk, but essentially you have a connection per process. So if you have a large number of processes, that's something to consider too.
Yeah, but I think we've tested at least up into the thousands of services connecting to App Insights. And
I think it can handle pretty high volume.
It'll handle pretty high volume so far. So I think.
So it may not even be an issue for you, but it's just good to be aware of it.
Okay, next question. Where are we?
Is there an ARM template?
Showing the DMZ approach. Check over your docs and the ARM template for the
Yeah, so there is one. So let me find it and just put it in the.
Yeah, let's post it into the window here.
So it doesn't address. I mean, it has all the knobs. You will have to tweak it. But I'll give you a starting point.
Greg asked, to follow up on my DMC question, we didn't answer question 3. Where then does the cluster live on my network? In the DMC? Do you have the context?
Yes, and the cluster is inside the network security group, yes, which in fact all of the cluster, front end and back end, is inside the network security group. If that's the answer to your question. So you typically have a front end set of machines, back end set of machines, and that entire cluster with both your node types is inside the NSG.
In one VNet.
In one VNet, yes.
Yeah.
Any comments on the new application inside Service Fabric versus with event flow?
It's awesome. I mean, it's a lot better than it was before with the agent that would upload to table storage and then you upload it there. It's a lot easier to use now. Yeah. Deep maybe has it.
Yeah, the main things that you want to see for the way App Insights has been able to do things is definitely check out the new dependency tracking and correlation context stuff that they've done. So by adding a context call in every single one of your service calls, you can create a very nice app map, which will allow you to see all of these applications and services running on a cluster, and you can dig into each operation that is happening in your cluster via an operation ID that allows you to track every single thing that's happening, spanning all of your apps and services. So it becomes really easy to diagnose any bugs or any issues or errors that the services are causing.
Overall, the setup has just gotten a lot easier because you create your app insights instance in Azure, and you basically get a key. Yeah, you get a key, and then you just give the key to your event flow config, and then it just works. And that's it, and it just starts sending events. I mean, I did this; it was amazing. Because before you had to set up.
It feels like I'm living in the future.
It's like you're living in the future.
We're tracing.
Exactly. Yeah, we're tracing actually works. Before you had to set up a storage account with table storage, and then you had to point to that, and then you had to set up graph insights to read from that, and it involved a few more steps. Much simpler to do now. Yeah, and you can just go into App Insights in the Azure portal and just view all of your logs. Now with the correlation ID stuff, you can actually do correlation tracing. So if you have tens of thousands of events and you just want to see what happened during one request as it flowed through your different services, you can just put in that correlation ID and it'll go and find all of that. So you just see, here's the request as it flowed through, here's where it went bad or when something went wrong. And it filters everything else out.
And there's a video that's
yeah, that's true. Yeah,
the video
that was Dan Taylor.
Yeah,
Dan Taylor posted a video.
Yeah,
that's on Channel 9. Yeah, maybe you can grab the link to that.
Yeah, grab the link.
Yeah, there's a good 15-minute video by Dan Taylor on Channel 9, and he just walks through pretty much everything I said.
Yeah, that would be
just now. That's a good one to watch. Yeah.
Is that the same correlation token that's going to be using to drive the map thing eventually?
Sort of, yeah. There's an activity ID construct that uses this correlation that will eventually then draw like an actual service map, like an actual drawing, a picture of a service map that shows you how requests flow through your services based on this activity ID that gets flown through. And this will be built into, if you're using the HTTP stack, this is going to be built into HTTP client and an ASP.NET Core. So
like .NET Core.
Just like .NET Core, yeah.
Not even
so you'll just get that for free. We do have plans to build that into our service remoting stack also at some point too. But if you're using HTTP, you'll just get this nice app map in App Insights, which is really cool. Check out the video though. It's
already
it's good, yeah.
Oh, great.
So I've seen an announcement on upcoming container networking. Is it going to work everywhere, or is it Azure and Azure Stack only?
So I'm assuming the two things that you're thinking about is having a static IP per container and the private VNet per application. So the plan is to make sure that it works everywhere.
Which means on-premise.
Yeah. It'd be Service Fabric standalone, it'd be Azure Stack, it'd be in Azure, it'd be wherever.
Yes. So which is quite challenging for us because actually it's two different implementations entirely. But we have this commitment that when you use Service Fabric, we make the features as, the same everywhere. So we're going to do the same capabilities on-premise.
Yeah. It might come in Azure first and standalone later, but the plan is to make it available everywhere. Ashu Dhingra has a question.
Is this general understanding when writing code for reliable services? Services can either go down because a node went down, or they can be moved by the cluster resource manager, also known as the CRAM.
Yeah, well.
So this question is failover. How quick is failover?
So how quickly is failover detected and secondary is permanent to primary? So that should be very fast.
Yeah.
The replica switch, that's what do we say?
It's usually
100 milliseconds.
Yeah, it's
instantaneous is what we say.
I mean, that part is switched. The promotion is fast. Then it gets kicked back over to your code. So it's really how fast your code can respond.
Spin up its communication listener.
Yeah, spin up the communication listener, start executing running sync. The failover part's really, really quick, and then it's really up to your service code to get spun up, get your replicas.
Typically, failures, it really does depend upon the type of failure. Usually, if the machine crashes, explodes in some spectacular fashion, blue screens, stuff like that, those get detected within a matter of seconds. And then it's the process that we were just talking about.
Yeah.
There are certain types of networking failures that are harder to detect or harder to figure out if the machine is cut off or not cut off. Some of those can take the outside envelope of those are by default 30 seconds. That number is configurable. Most of the time we don't recommend people configure it because we don't see it being the main source of failure. The main sources of failures are really like total failure and crashes of the host processes and things like that. Those are more of a seconds type of thing.
Seconds, not milliseconds?
It can be upwards of a couple of seconds to detect it. Because Windows is not a real-time operating system, we do get caught sometimes where we're watching this process handle and saying, is this process handle still there? And even though the process is dead, Windows hasn't informed everything that was watching that process handle is dead. So we just like to say, there's the There's a system resolution timer that's 15 milliseconds by default. There's a bunch of other things that can conflate together, and just sometimes it doesn't, react in a reasonable time. We've seen locks and deadlocks inside of the operating system. There's a whole bunch of horrible things that go on down that low in the machine. But the whole point is that normally it's going to be within milliseconds. The upward envelope that we see for process failure is usually a couple of seconds. The upward window for gray unidirectional networking failures that kind of like partially isolate the machine is like 30 seconds. Okay. So in practice, very quick, except in the extreme cases where multiple bad things are happening and we can't even rely on the operating system or the network, at which point it can be upwards of 30 seconds. But a lot of those timers you can make more reactive. The downside is that transient things that we would normally ride out, we basically are going to promote into actual failure. So, a machine blue screening is not that big of a deal, right? That one's pretty straightforward. You're going to want your stuff to fail over. When the network kind of just slowly fails or fails in weird ways, there are options to promote those into real node failures where we'll react and we'll move things around. The downside is that if you have a lot of those, we're going to be spending a lot of the cluster's resources moving things around and building spare replicas when really, maybe if we waited a little bit longer, everything would resume and everything would be fine. So that's where it really does get into a configuration choice that is in your control for how reactive and how responsive you want us to be, knowing that we will be spending more resources reacting to stuff that maybe you could have written out. I hope that makes some sense.
That makes sense, yeah.
Yeah, one other thing. So I've seen some customers running in prod with 3 replicas. In Azure, my recommendation, at least, this is my personal recommendation based on what we do for system services. We always run with 5 replicas. So that should be your way of surviving any of the other things which might happen to you. So I would say, if possible, run with 5. 3 is the minimum you need anyway.
Yeah.
And that will get you out of any other combination of issues you might have.
The second part of your question, this is a good one too. So it is a cooperative cancellation. When the resource manager asks you to move, we will signal that cancellation token and call your close method on your communication listener, but we wait until those complete. So you have to respond to those fairly quickly. If you don't respond within, I think, 4 seconds or so, we start issuing warnings against the service. But it is cooperative. We wait until you finish all the work you need to do, but we expect you to do it very quickly.
On the last part there's one correction, which is that we don't promote the secondaries to primaries until the existing primary is guaranteed to be shut down. Service Fabric is a strongly consistent system. We guarantee that there is only ever one active primary, period. So the order there is the existing primary gets shut down, the new primary gets promoted.
But if you change your naming service, that's it. Everybody is done. Every new call will go to a new primary. Nobody knows about the old primary.
Yep, and that's why we don't tell the new primary that it is the new primary, or we don't start advertising the new address until that primary, the new one, is actually promoted. So the real sequence of events is old primary demoted, new primary promoted. As a part of primary promotion, that service tells us its listening address. That listening address then goes into naming, and that's when the new service is actually, or any other connections would now fall over to that new service.
I got it.
So there is a window. That's why we were saying, we do kick it over to the service code fairly quickly. So if we say, hey, you're the primary now, and it takes 30 seconds to spin up the communication listener, that is 30 seconds where there isn't a primary. And that's why it's very important that those types of chunks of the code be very responsive and return that information back to the platform quickly.
And same with your shutdown code too, because once we've signaled your replica that it needs to be demoted from primary, you can no longer do write operations
to the collection.
To the collections. If you're using reliable collections, your write operations will no longer work at that point until the new primary is up and ready to start taking those writes. So there's a window there that is really up to your service code to make it as small as possible so that your write operations can continue through. And meanwhile, your clients will have to wait. They'll retry and they'll have to wait a second or two until that process is finished. So shutting down as fast as possible
is ideal.
Is the best thing you can do.
Especially when you're trying to do work on those collections. by the time we signal those the primary to shut down, in a lot of cases, the ability to write to those collections is already gone.
Right.
So there's not going to be a lot of work that you can do. I mean, if there's something that you're finishing processing on, that's an option. But you won't be able to make any further progress, right? No writes will succeed.
Right. Usually requests that are in flight that want to make a write operation, they're gonna fail, and you're gonna kick that error back to your client with some message that says you're now talking to the wrong replica. Please re-resolve. And by the time they do re-resolve, hopefully the failover is completed and they can continue to write. But they may end up having to retry a couple times in there. That's why on your client side, if your client is another service, it's important to do some kind of a staggered back off if you get those errors from a service that says, hey, you can't write to me anymore. The client should do some kind of a staggered back off, say, well, I'll try again real quick. And if it doesn't work this time, I'm going to wait a second and then try again. If it still doesn't work, I'm going to wait 2 seconds and then try again. That way you're not overwhelming.
Yeah, you're not hammering on it.
Yeah,
the other thing to be aware is that you can lose rights. You can lose write status for all sorts of reasons, some of which are transient.
Exactly.
And that's why this backup thing, the client doesn't really know whether or not it was a transient failure or a permanent thing.
Yeah, that's true.
There is data that you can look at, but we would expect most clients don't peer that deep inside. You're going to send a message to the thing, try and do a write, get some sort of transient error that says that this didn't work, and try again. What might happen is that you get a different address back, and that's when you connect to the new primary and just keep going. But really,
that back off is important.
Is important.
It's like when you're looking at a website and it fails so low, you hit refresh, and it still doesn't load. You say, okay, well, I'll wait a few seconds this time instead of just hammering on refresh.
I mean, you can just
I
mash
guess you
F5.
can just mash F5, but usually that just makes the problem worse.
Yeah. All right, let's move on to this one then. So on-premise.
No, there was a question about
But if I-
durability.
But if I understand correctly, reverse proxy does this nicely, yes? The retries.
Yeah, that's right.
Yeah, the reverse proxy handles all this for you.
And the service proxy as well, if you're doing remoting, it does exactly what we described. It does a back off that kind of it's an exponential kind of back off.
Yes. Okay. Using reverse proxy. So
Silver
Silver
Chaco.
Okay, so I know. So I know I have to walk this thing very carefully. It's a very tight time.
For those
tightrope.
new to the call, Chaco's been getting beat up about silver reliability for a while now.
So there is a new schema which we published as a part of build, which is called 2017-07-01 preview. So if you switch your ARM template to that particular schema for when you're defining your resource service fabric, you actually should be able to use Silver. If you're not able to...
I did this.
Yeah, okay. So then there is something else going on. You need to let me know what happens. So today there isn't... Yeah, there isn't anything which will prevent people from getting it. We just have not announced at this point. So
But should I also switch this for VMSs or only for the Service Fabric cluster?
So the Silver as a dropdown is understood only by Service Fabric. So everything else basically is derived based on that. So it's not a VMS setting. It actually is a Service Fabric setting. So you would see that as soon as you turn on the Silver, there will be a new service called Infrastructure Service, which will be spun up. And after that, it should just go through. But we will do a better guidance
It sounds
soon,
like
because there is internal drama going on. So I just wanted to get over that, and then we'll.
But I think post what you've tried on the GitHub issues, and we'll take a look.
Yes. Yeah. Thank you, Marcin. Good question. It gives me the ammunition I need.
All right. Can we have Service Fabric on-premise recommendation or factor we should consider when we add more nodes using Azure VM? I think this is about how do I scale in and out on-premise. Yes. I mean, what I do with that.
Yeah, so there are PowerShell commands which actually allow you, as a part of you would see add node. So here's the interesting part. So let's just step back, tell them what really happened. So 5.6 release is coming in a week's time.
Ideally.
For on-premise coming a week from now. We're doing the final testing to support containers, and that's why the delay. So that actually has add nodes, remove nodes as first-class citizens.
Yes.
And then in that, all you do for an add node is basically change your cluster.json, add the new IP address, and it should just go through fine.
Yeah. So that's coming. Easier to use PowerShell commands on premise, and our release it comes next week.
Yes.
Yeah. And then the other question is, I'm going to create new instances of stateless service from the Explorer, or is PowerShell the only way?
You can do both. There's a new, well, okay, when you say instances,
Yeah.
do you,
They're pre-provisioned.
okay, yeah, so you can create instances both in PowerShell and through SFX and through HTTPs. There's another thing that we added in SFX that we called it scale. That creates more instances of one of the instances.
So let's be sure that a service has a name.
I'm gonna draw this.
Yeah.
Well, yeah, I think there's three
forms
pieces.
the picture. Okay.
Yeah.
Because the terminology is confusing here. So
Yes.
you have one service package. This is your compiled code. I can create an instance of it which has a name that looks like this: fabric/app, and then a name A. And then I can say, imagine these are my nodes. I can say instance count equals 3, and we'll put A here, here, and here. So you can do that. You can, or if you say instance count 1 or 2, you can change this instance count number anytime you want. So you can do that in PowerShell or through
Once I said 3,
SFX.
let's say I went and said 2, right? What would happen? If I went and changed the
If I
instance
change
count.
this to 2,
Yep.
then we remove this guy.
Yeah, we
and
would
now you've
drop
got
some
2.
of one of the instances.
So that's what we call scale the service out. We call that scale in SFX. It does that. You can do that in PowerShell through what we call an update. It's update service fabric service. Now the other thing is instance. You can create a new instance of that same code package or that same service package and give it a new name. Call it B, and then you can say again, I want instance count 3 for that one, and we'll put B here. We'll put B here, and we'll put B here. And then you can do the same thing. I want to change that to 2, and we'll remove one of them. So this we refer to as a service instance. And if it's stateless, it has a number of instances, which we call instance count. So we unfortunately use the word instance twice there. It's kind of overloaded, but that's what that means. You can do both, all of these operations in SFX and in PowerShell.
Yeah.
Or C#. Yeah. Create service async or update services.
Or REST.
Yeah. Or HTTP. Yeah. Yeah.
Okay.
Actually, I have to plug something in.
Go.
So although the capabilities exist to go do it in SFX, think about, again, I'll bring up this disaster recovery scenario. Think about that scenario. If you have to recreate this cluster somewhere else, will you remember what instance it was? If it's not, then treat all your config updates as code.
Mm-hmm.
So I would strongly suggest not to use SFX as a way to up or scale out or scale in any of your stuff, because you will not remember how many instances that were when the cluster went down. So this should be treated as code. Treat the config as code is what I would strongly suggest. That's the best practice. But capability-wise, yeah, you can.
Okay, we got 10 minutes.
Okay.
So let's try and
Marcin asked, how can we really be sure a machine is blue screened? That is like one of our only jobs, is to make sure that we know when a machine is blue screened.
Yes.
So there's a computer science thing called a perfect failure detector. We have one. It took some work.
To write.
Yeah, it took a long time to make one, but that's how it works. Cannot imagine any way promoting new primary before lease expiration. Yeah, there's no preemption. You can tell us, you can fault the services yourself. There are APIs for that. But if the process is there and the machine is not declared to be dead through the failure detector, that service is going to keep running. Question is there any way to mark a service unmovable from a node? No, we don't offer such an API because there's no way to really guarantee it. As you noted that nodes can fail. What we do say though is that the only reason Service Fabric is going to move a service is because you told us to move it. You tell us to move it for a bunch of different reasons. For example, you might say balance these services according to these metrics, or move these services when machines need to be defragmented, when you want to crunch a bunch of load onto a bunch of fewer machines. So the only reason we're going to move a service in the first place is because there's something that you've told us to do to ensure that service should get moved. So if you're seeing services move and you're saying, well, I don't want them to move, go look at your cluster resource management configuration. There's lots of knobs available to describe what services should get moved and when. There's ways to give services weight so that it's less likely that they get moved. There's ways to describe the capacity of nodes so we know we don't need to move them. There's all sorts of things that describe when we should be moving things, but there's no specific API that says somehow make this unmovable.
But in this particular case, you could give it a large weight. Yes.
There is no weight or no cost that you can give it that guarantees that it won't move.
I didn't say the guarantee is we wanted to make it more stay in one place.
Yep, that is one of the knobs that you can turn, but it is still never a guarantee.
You can make it harder to move, but you can't make it
You
impossible.
can make it exactly.
Yep.
Okay. Yes. If I was designing a system at 500,000 actors in it, and I want to broadcast a message to all of them as an article reference pointing to that scenario. Well, we don't document that scenario specifically, but all the pieces to do that are there in the documentation. You can, we document how to get all the IDs for all of those actors, and then of course, sending a message to those actors is what you normally do.
Actor proxy.
And this would basically mean you do a query for 500,000 actors, and then you send 500,000 messages from your client. I don't recommend doing that because it's going to be really slow.
Yeah. Is the continued value driver prototype using reliable dictionary, or is it using some kind of new kind of collection, or is it using the underlying APIs? We're not going. Yeah, it uses some stuff.
Yes, stuff. It was just a prototype.
Yeah.
It uses reliable dictionary.
No guarantee that it's even going to stay that way.
Yeah.
Yes.
Okay.
I think that's it.
I think that's it. Ha!
Yes, unless there's any final questions.
Oh,
we got one
there you
more.
go. All right.
Service Fabric is considered a platform as a service. Can you describe the value proposition here?
Yeah, I mean, Service Fabric, the way to think about Service Fabric is it's a platform for helping you build services. It can be hosted in many different environments. We host it in Azure as a service. It's a service that gets hosted inside your subscription, so you can create as many of these hosted clusters, as we call them, inside any number of your subscriptions. But like .NET as well, you can also host it on premise. So it spans this boundary of effectively building clusters in different environments. So the value proposition effectively is all the hard problems of effectively building a distributed app, detecting failures, detecting rollouts, upgrades, diagnostics, monitoring. All of that isn't the work that you have to do. You have to think about building an app, because effectively when you build services today, they're multi-machine application, they're multi-machine. I mean, all things when we talk about cloud are multi-machine applications, and so you need a thing to help you. Just like you have an OS on a single machine, help you as a file system and a whole bunch of things there. What's the OS or platform you need for a multi-machine environment? That's what Service Fabric does, and it runs everywhere.
And the API part is out there as well. So how do I think about actually building my application? What is the application platform that I need to actually use, can I use, to make applications more suited to this environment, right? So we know that with Service Fabric, you can pick up just any container, any guest executable, any chunk of code, and just throw it at Service Fabric and say, please make sure that there's 3 or 5 or 7 or 9 of these. But that's not necessarily taking best advantage of the cloud or of the capabilities of the platform. So Service Fabric does have that other ability as well, where we do have these APIs that allow you to write services that are more targeted to that cloud scale, partial failure, all sorts of.
Well, that's why you hear everyone talk about orchestrators now.
Right.
But I mean, orchestration is just one piece of a distributed systems platform. It turns out to be a very important piece, because it's how you place and activate those things, or containers, or process across set of machines. But as Matt said, there's many more things to that in terms of rollouts and diagnostics and programming models that help you.
Yeah. Can you hear me now?
Yes.
Yeah.
Hey, imagine that. Cool. Okay, yeah, and I'm actually inside of in a training right now with a bunch of different architects and talking about Service Fabric and sort of pushing the platform as a service. And I understand the being able to do on-prem, being able to write the application with the understanding that the cluster will manage the deployment capabilities, et cetera. One place where I struggled, and I think it's one of the advantages of a platform as a service, is that I was sort of assuming, but I didn't really find it necessarily on Azure. And this is because I'm an on-prem guy and I don't know enough about Azure, but just talking about Service Fabric in general, I want to have it shine in the best light possible. Is like, do you still manage all of the hardware? My assumption is that managing the hardware when you're dealing with a platform as a service is that from Azure, I can buy, I've heard you guys talk about the silver and gold subscriptions and whatnot, and not have to manage the hardware as much. Is that true? Or is it still you're managing your cluster hands-on just as much as you would if you had, from a hardware-only perspective?
Yeah, the answer to this, I think I'll give this, is it's not as hard as on premise. You have to do a lot more work. You have to
Right.
stand up the physical machines. You have to think about your failure domains. You have to think about your network cables. You have to patch all the machines. You have to update Service Fabric on those. It's just kind of a semi-managed environment inside Azure. The things that we do provide for you is we will patch and update Service Fabric runtime across all those machines. We will pick machines for you across failure domains, so you don't have to worry about where they are. We provide a patch orchestration service that actually patches at that level, and soon there'll be VM-based patching around them all. But
well, and also just scaling is easier, right? I mean, if I say I need more resources, they're pretty easy to come by. They're fairly easy to hook up to the cluster, and that's a fairly automated sequence. Whereas that exercise, if your physical resources are hot on-prem, it's a lot harder to stand up more machines because you might not go buy them.
So it's kind of a semi-managed one. It's not like, I mean, if you compare.
Let me sort of throw what I'm being compared to is every other solution that's being proposed, because we're all, as I said, in architecture school where we're discussing different solutions, we're throwing this thing and this is how you're going to solve this and create this architecture. Every other one is using individual AWS virtual machines, having a web layer, having a app layer, and having a database layer as a classic NTR architecture. And that's one of the questions, that's one of the reasons why I asked the question about the cluster previously, about using the DMZ, because you could literally have one cluster with different cluster or node types and just have that your architecture changes dramatically. You don't have that web layer and the app layer and the DMZ and the firewalls in between. So, but I thought one of the other advantages was going to be, I thought there was going to be some advantage in the area of the maintenance of the hardware that the cluster runs on, because you're buying a platform as a service instead of buying infrastructure as a service, where you're buying those servers and then you have to install, whatever you have to install and maintain them. So I think what you're saying is the automatic updating of the Service Fabric runtime itself is there, but we still have to manage those individual servers.
So let me take a crack at this. So if you look at the cluster, and then you would see that behind the scenes there is a VM scale set. Each of these VM scale sets, is the one which you buy, and the only additional thing you're responsible today, as Mark was saying, to maintain is the OS image itself. So OS patching is the one which
going away.
And that actually is going away in the next 2 weeks or 2 months. We would actually have image-based patching. Till then, we will release this platform, this patch orchestration service, which will patch. Beyond that, there isn't anything a customer is expected to do.
Perfect.
If the hardware fails, you get a new VM. You don't really care about the hardware. In fact, you're not buying the hardware at all. You're buying
exactly. Exactly. Yeah. That was my understanding of the advantages of the platform as a services. You only care about the application.
Yeah, that's the idea. It's just that on-prem you have a little more work to do because it's very hard to stand up physical machines.
Yeah. And the other thing is,
no, I'm not worried about my on-prem. I'm just trying to show these guys a little bit of a different approach than just going the straight.
And there is an approach at application design as well. I mean, traditionally it used to be I stand up one database, I build my app, I have a middle tier, and then I hit some scale bottleneck. And then I have to re-engineer again to have 2 databases, and then I have to scale my web tier out. And you had to do all this sort of re-engineering between them all. If you think about a cloud model, it should start small with a few machines, and you should just be able to scale your service by adding machines and adding instances rather than redesigning the whole time.
Right.
And that's another fundamental difference.
Well, thanks for helping me install Skype for Business on my phone and your time.
Another happy customer. All right, we got one. Okay, we're going to wrap it up.
We literally have to blast through the last 2.
No, I think that. Oh,
there are
3. Okay.
One is regarding a pub subsystem.
Yeah, I don't think we have one.
We don't have one. I mean, we have a series of pub sub features in Azure: Service Bus, Event Hub, IoT Hub. Please use those. They're built specifically for that, and we kind of don't want to rebuild our own just for Service Fabric. It's something we may add at some point to the programming model as a rudimentary version, but use Service Bus. It's designed for it.
Yeah, it's pretty good.
Yeah, it's good. Is that it?
Yeah,
Marcin wants the secret sauce.
It's a prototype.
You don't have one yet.
Yes, wait for the real thing. Yes.
Okay.
That's it. Okay, fantastic.
Thank you, everybody.
Thank you.
And we'll see you next time.
Yes.
Thank you.
Have a good month. We'll see you.